Okay, you all need a warm-up question?
Yes.
Okay. And let's look at exercise 4.4, question 3A. Okay. Let's use this question as a warm-up. We have 8x squared minus 11x plus 5 over 2x minus 3x squared plus 1. Okay? Warm-up means you're doing yourself, huh? Okay, can I give you about 5 minutes? Okay, first, to try and solve this question yourself. Break it down into its partial fractions. Okay, can I talk about certain stuff regarding this answer? Alright. Now, as I walk around, okay, some things that I noticed and I thought that it is helpful for me to bring it out. Okay, first thing, from this step here to this step, okay, when we multiply across by this denominator here, okay, you notice that you get a times x squared plus 1. Just want us to be careful that bx plus c is together, so there is a need for there to be brackets around this entire bx plus c. Okay, so please do not leave that out, okay, for this set of brackets. Another thing to take note is that, okay, if you want to try to make x squared plus 1 to be equals to 0, that is actually not possible. Okay, because x squared plus 1, if you were to solve it, okay, and equate it to be equals to 0, that means x squared equals to negative 1. This is not a solvable equation, so there will never be a value of x, okay, that can make x squared plus 1 0. Okay, so if you went to think about negative 1, please be aware that negative 1 bracket squared is positive 1. So not possible at all. Okay, so you cannot actually make this part here 0. Okay, so you have no choice but to start off by finding out the value of a first, and that is by letting 2x minus 3 to be equals to 0. So at the start, I see that some of you are stuck because the impression seems to be wrapped around that your value of x must actually be an integer. So that's not necessarily the case. Okay, for some of us, maybe we are not able to see immediately what is the correct value of x to make this to be 0. It's perfectly okay. You can do a very quick side working to see what is the value of x. Then you can make this decision. Okay, so the side working is okay. Then yesterday, Yuting actually came to me after class and asked me, okay, is there a shorter way? Okay, instead of doing all this long working over here to determine what is the value of b and c. Okay, she wants a more efficient method. Actually, there is. Okay, remember when we learned chapter 4.1, okay, other than doing substitution of suitable values, another concept that we learned was by comparing coefficient. So comparing coefficient might sometimes be faster and easier for some of you, provided you can do that observation fast enough. So for example, if you want to find out, let's say, the value of b, so no matter what at the start, you need to find the value of a first. Okay? So at the beginning, it's always trying to use a substitution of suitable values first. Okay? After I found a already, I want to find b and c. Okay? How can I do my comparing? Okay? Quick enough to help me to find b and c. Okay? So for b, you notice there is a bx. Okay? Maybe you can think about comparing the coefficient of x squared. So having bx, to get an x squared term, it has to multiply with 2x. Okay? So you will get a 2bx squared. Right? But that is not the only thing you get when you expand this entire thing. We also have a with x squared. So I will have a ax squared as well as a 2bx squared. So it compares with this coefficient over here, which is ax squared. So one faster way to find out the value of b is perhaps to let it to be equals to a plus b. Since I I already found out the value of A that is equals to 2, we know that 2B will be equals to 8 minus 2, that is 6. So B is equals to 3. Okay? So you need to have that observation. Alright? Okay? Otherwise, you can of course extend the entire thing, which may not be the most fun thing to do, so expand it. It really depends on your preference. Right? Then you want to find the value of C. Okay, after I found B already, you want to find the value of C. So for C, maybe you can look for the constant term. So to get the constant term, we get C with 3, or rather negative 3. Okay, and that will give us a negative 3C. Alright? And then don't forget, this expansion here also gives us a constant term, that is A along with 1. So I will also have a plus A. Okay? And that is to be equals to 5. So I can have 5 to be equals to A minus 3C. And since I already got A, my 3C will be equals to 2 minus 5. That will be negative 3. So C equals to negative 1. Okay? So you may find this shorter rather than always sticking with substitution method. So I want us to be flexible in using these two methods because you may find your own style in solving these questions. Okay? Are we warmed up yet? Okay? So we are kind of done figuring out how to do our partial fractions for proper fractions using the 3 different types of denominators that we have. So what I want us to do today is to learn how to handle improper fractions. So let's look at try 22. Proper or improper fraction. Okay, so in this case, looking at the numerator, it is a degree 3 polynomial because the highest power is 3, and then in the denominator, it is actually a degree 2. In case you're wondering why degree 2, because if I expand this whole thing, x times x will give me x squared. Okay, so therefore it is a degree 2 polynomial. Alright, so with this fraction over here, okay, since it is improper, the first step we have to do is to do long division. Okay, so we have no choice but to do long division, yeah? So we got 2x cubed minus x squared minus 8x plus 16. Divide by what? Divide by the denominator. So you got to expand the denominator. That will give us x squared minus 2x minus plus x minus 2. Okay, so divide by x squared minus x minus 2. Okay, sometimes your long division actually not that long one. Alright, so it will just be 2x cubed minus 2x squared minus 4x minus and plus 2 will give you plus x squared. And then minus 4x plus 16. Okay, so we will have plus 1 x squared minus x minus 2 minus plus minus 3x 16 minus 2 plus 4. Okay, then we stop here already because we stop when the degree of the polynomial is lesser than the divisor. Right? Then from here, okay, after doing our long division, then what? Right? So what this tells us is that with the given fraction that we have, okay, upon dividing, we actually get the quotient 2x plus 1 plus the remainder on top of the divisor. Okay, this is what we understand, yes. Sorry, it all. Thank you. 18. Okay, so we are going to re-express it into this for the given fraction. Okay, in case you forget what is the format that you're supposed to write it in for doing an exam or your test or whatever, okay, you think about a simple division, okay, about how we maybe take 30 divided by what? 4? Okay, I hope you know that 30 divided by 4 will be 7 times of 4, that's 28, okay, then after that plus 2 over 4. Right? Okay, correct or not? We agree, 30 over 4 equals to 7 plus 2 over 4, right? Okay, so if we do a long division, okay, how do I know which part go where? Because sometimes we'll get ourselves confused, right? We don't know, is it the remainder put here or the even, okay, or the quotient put here. Okay, so 30 divided by 4, we know that if I were to do my long division, okay, maybe you don't know how to do your long division for numbers, that's fine. But you must know that 7 appears here in the end, your remainder appears here in the end part. Okay? So based on this, you figure this out, then after that, you figure the format out. Okay? So this is supposed to be your quotient, and then this is your remainder. Yes, it's an example. Yes. Okay? Now we appreciate stop appreciating my class. Alright, so from here, what next? Okay, why do I need to do long division? My purpose of doing long division is to address the fact that this is an improper fraction. Okay, after I've done a long division, I get this so-called whole number part, which is your quotient, and then also over here, I'm getting a proper fraction. So we apply the partial fraction decomposition to the proper fraction. So we can just place our focus on this cell. That will give us a over x minus 2 plus b over x plus 1. Okay. Then our steps in terms of doing partial fractions will be the same. So this one, I think we are familiar in terms of substituting suitable values. So I will not re-emphasize on it when x equals to -1. Following this form here, where a is 4, so plus 4 over x minus 2 plus b, which is -7, so minus 7 over x plus 1. Okay? So remember to answer the question. Any questions? Shannon, please speak up. Okay. I know that the heat is getting very warm. That means you get fans. Okay, no fan over here or not? Yes. Here we have glass. Why then? Remember down here is glass, right? Then your B is -7. Okay. I think it's switched on. It's turning. It's turning here. But it's quite ineffective. Okay, yes, always ineffective. Okay, you want to give it a try? You want to try? Okay, so let's do exercise 4.4. Question 6. C. Okay, let's do this and put it into partial fractions. Okay, this is improper despite it being the same degree. So this one is degree 3. In the denominator it is also degree 3. Okay, when the degree of the polynomial is the same in both numerator and denominator, it is still considered improper. Okay. So expand the denominator so that you know, okay, how to do the long division. I'll give you about 8 minutes. Okay, I hope you're able to find A, B, and C, right? And of course, to re-express the answer, I've not yet written down the answer. Okay, the answer in the end should be 3 plus, okay, whatever that you have over here. Alright, so should I still write it? It should be 3 plus 4 over 2x plus 3. B is -3, so minus 3 over x minus 1 plus C, which is 2 over x minus 1 squared. Okay, so the one that I wrote in black here is the answer. Okay. Alright. I hope you understand that when it comes to partial fractions, actually it's not difficult. Okay, it's not difficult. It's just very tiring and tedious. Okay. Other than that, it's actually not difficult. Your steps are actually the same all the time. So I've written here a flow chart that you can consider revising with, okay, whenever you're dealing with partial fraction. So always it's about checking whether it's improper or improper. If improper, must do long division first. If proper, then you express into its decomposition, meaning to say this part. Okay? Then after that, you find the value of the constants, okay, by substituting normal values or by comparing distributions. Then always remember, answer the question, like what I've written in black here. So the steps are actually quite standard. And I think that is also the thing I want us to be able to notice when it comes to A-maths. So actually A-maths is not difficult. Okay? The steps are usually very straightforward, okay, one after the other. Once you get the hang of it, it's just very tiring. That's all. Okay? So A-maths is not challenging but more tiring. Okay? So I don't know whether any one of you at the back of your mind are wondering how many marks is a typical partial fractions question? Any guesses? 5, 4, 6, 4, 8. This one I will 6 lah, okay? Yeah. So maybe 1 mark for me want to get this. 6 marks. No, it shouldn't. Okay. Then after that 1 mark. Wait ah. 1, 2, 3, 4, 5. And then down here is marks. Okay? And unfortunately I have to share with you that this 6 marks eventually may be a part of 10, 15, 10 mark question altogether. Because later on when we go to set 4, okay, we are going to learn integration and this will form a foundation to doing that.
So if a 10 mark question, if you get the first part wrong, your 10 marks not gone already.
Yes, yes, so yes. Area have you must have some cooking lah. Maybe it depends on what kind of 6 So just hurry now, alright? Okay, shall we move on? We got about 10 minutes. I was looking through 3 questions that I picked up from the exercise that might be challenging. Okay, and I thought that maybe I just want to do one of them. Okay, then we wrap up this chapter. Okay. Because we have not yet looked at something of this form. Okay, look at question 15 now. Okay, are we ready? Let's look at the last one for the day and for this chapter also. Okay, I think this question also quite nicely sums up the chapter for us. Okay, part I is asking s cubed minus 8 how to factorize. How should we factorize s cubed minus 8? Do you remember?
Yes.
How? What is the acronym? Right? Okay, so this is your s cubed minus 2 cubed. So what does SOAP tell us?
Same, opposite, always positive,
always positive.
Yeah.
Okay? So simplify it. Get this up. Okay? Can factorize further? Cannot. Okay? So this cannot be further factorized. Alright? Let's look at part 2. Okay? In part 2, right? Okay? It says hence express x squared plus 4 over x cubed minus 8 in partial fractions. Okay, this one is proper. Okay, so we don't have to worry about your long division. Okay, so in part 2, here is the proper number. The problem is that the denominator is not expressed into its factors for us. Okay, we need the linear factors in order to know what is the decomposition, right? So s cubed minus 8, we rely on part I to tell us that the factorization is this for the denominator. Okay. Then, how will the decomposition look like? Okay. This one can factorize that. This one we agreed here cannot factorize anyone. Okay. So, in this case, it cannot be further factorized, yeah? So therefore, I'm looking at x minus 2 and x squared plus 2x plus 4. chosen A first, right? For this one, it will be, is it just B? Bx plus C, yeah? Okay, so that's the thing that I want us to be aware about. Because very often when we're dealing with the quadratic non-factorizable kind, okay, it is usually maybe x squared plus 4. They don't have the plus 2x. So I want us to observe that the x squared plus 2x plus 4 is actually quadratic and cannot be factorized. So it's the type 3 that I was referring to. Okay, the third type. Okay, so once you get the decomposition, then we can proceed to find the value of A and B by first re-expressing it into this. Okay. Let's work on this together. What constant should we find first? A. And how do we do that? X equals to? So 2 squared plus 4. Okay, I know some of you, by the way, you're lazy in terms of substituting here. Just use your calculator, find the value, also can. So just press, but make sure you press correctly. Okay, so 2 squared plus 4, that's 8. Right? Then after that, this one A. You can go and press calculator for 2 squared plus 4 plus 4. So that will give you 0.44. Okay? So actually, if you're good in mental calculation, there's benefits to it. Okay? You don't have to rely on calculator too much. So in this case, A will be equals to 8 over 12. Right? And that is equals to 2/3. And that's something we have also not seen before because our constants have usually been integers. Right? In this case, our constant is now a fraction. So we need to learn how to express it as our answer later on also. Okay? But before we do that, let's find B and C. So to find out what is B and C, okay, up to you, what is it that you like? Alright, you can do substitution of values or do comparing of coefficients. I will maybe consider when x equals to 0 first. Okay, so that will give us 4 on the left side. And then A, 4 plus 0 plus C, 0 negative. A is 2/3. Okay, so we have 8 over 3 here. 8 over 3 minus 4, 4 over 3, negative 4 over 3. And C is negative 2/3. Okay. Then to find B, you can consider comparing coefficient. I will likely do that. Where Bx and x gives us our x squared term, and then A and x squared gives us x squared term. So comparing coefficients of x squared, I can say 1 is equals to A plus B. A is 2/3. And B is therefore 1/3. Okay? Understand? You got your question?
Explain again why A plus B equals 1.
Why A plus B is equals to 1? Because comparing coefficient of x squared, A and x squared, Bx and x will give us our x squared term. Right? And then coefficient of x squared over here is 1. Okay? Yeah, Melanie. How to get the final answer? That's the thing I want to address last. Okay, so now, because our constants are all fraction, right? Okay, how do we write our final answer? Okay, I'll just write on this. Okay, so A is now 2/3. So of course we cannot put 2/3 over x minus 2. Okay, so actually we can put the 3 below. In case you don't understand why, give me a moment, let me explain. Okay, for B and C, just nice both are having the same denominator. So I will have x minus 2 over 3x squared plus 2x plus 4. What if they don't have the same denominator, then your life will be very challenging and difficult. Okay? You have to make same denominator first for the person. Usually won't be that way. Okay? So explaining why 2/3 over x minus 2 gives us this. You think about it, 2/3 divided by x minus 2 over 1. Keep big change. Numerator times numerator, denominator times denominator. Okay, so that's the explanation. Okay? Alright? Now, homework, unfortunately. Okay. Sorry. I know time is up. Okay, got to go and practice so that you can solve questions fast. Exercise 4.4. Please do question 5. ABC. 6A.
6A.
Yes. And that's it. Okay.
Really?
Yes. Where is it you? Next Monday, can
Oh, yeah.
Next year you'll be there yourself. Okay. So 15 of April.